Hello, everybody. Welcome back. Today we are going to be talking about how to use initial conditions to figure out what that plus c or what that constant is whenever we take indefinite integrals. And then we'll also do some motion applications where we do some position, velocity, and acceleration applications. So here we go. So originally, we have been given statements about derivatives, and this is called a differential equation. In a differential equation, you're given a statement about the derivative, and your goal is to figure out what the original function or what f is. Because of the constant of integration c, we end up with a general solution. We end up with something like something x plus c because we don't know exactly what that constant is. But if I'm given an initial condition, like f of 0 equals 5, where x would be 0, that would be set, the whole thing would be set equal to 5, that's going to allow me to solve for that plus c so I can have a specific solution to the differential equation. So here is what I'm going to have. I have this information right here. F prime of x equals 3x minus 1. And here the f of 2 equals 3. This is the initial condition. So my goal is to write an equation for the original function and also figure out what is that plus c so that I can have an entire equation. So when I start this off, I'm given f prime. If I want to find f of x, I can say that f will be the indefinite integral of this 3x minus 1. And then I need a dx to tell me to stop taking the indefinite integral. I'll use this f of 2 later. But let's find the antiderivative. So f of x equals the antiderivative of 3x would be 3/2 x squared. Antiderivative of negative 1 is minus x plus a constant. So this is called a general solution. Because it has this plus c here, it's general because it could be 3/2 x squared minus x plus any constant that exists. Now, if I want to find the specific solution, I need to involve this initial condition. This is telling me that when x is equal to 2, the entire expression will equal 3. So what I do is I take this expression, I substitute in the 2 for x, and I set it equal to 3. Doing that allows me to figure out what the c constant is. So 3 equals, let's see, that would be 3/2 times 4, 6. I can't do that in my head right now. 6 minus 2 plus a constant, 6. Let's see the whole screen. 6 minus 2 is 4. So 3 would be 4 plus c. So it looks like I'm getting negative 1 for c. So since I know that c is negative 1, I can write my expression or my function with c substituted in. And I can say that f of x equals 3/2 x squared minus x, and then instead of c, minus 1. This is called the specific solution. It's right here. And I can find the specific solution as long as I have an initial condition. So we'll see this today, but you'll see it a lot with applications embedded in position, velocity, and acceleration. So just a reminder, before we got position, we said the derivative of position was velocity. Well, now, instead of me giving you position and you telling me about velocity, now I will tell you about velocity, and you have to tell me that about position. So if velocity is the derivative of position, then position is the antiderivative of velocity. So if I want, so position is the indefinite integral of velocity plus constant. Well, that plus constant comes with respect to time. dt. And I'm using t instead of x because I have this variable. And then if I want velocity, well, that's going to be the indefinite integral of acceleration, dt. So keeping that in mind, let's look at our first example. A particle moves along the x-axis with velocity given v of t equals 10t plus 3 for the time t is greater than or equal to 0. If the particle position is at position x equals 6 at time t equals 3, what's the position of the particle at time t equals 2? So right here, they're giving you a position and a time. This is the initial position. Or then not position, sorry, initial condition that they're giving us. So they're telling me that x of 3 is equal to 6. So the position at time 3 is 6. Okay. And they want me to find position, so I'm going to say x of t equals the indefinite integral of v of t dt. I have an equation for v of t, so I'll substitute that in. X of t equals the integral of 10t plus 3 dt. I'll go ahead and find the antiderivative. So add 1 to the exponent, I get t squared. Divide by 2, 5 plus 3t plus a constant. And notice, see how I have t's here is because of that with respect to t part. All right, so this again, this is the general solution. To get the specific solution, I'm going to use this, which means I'm going to substitute 3 in for all the t's. And set it equal to 6. So 6 is going to be, let's see, 5 times 3 squared would be 5 times 9, 45, plus 9, plus the constant. 6 is going to be 45 plus 9, 54, plus c. So if I subtract 54 on both sides, I'll get negative 48 for c. So now I can say that I know my formula for position is x of t equals 5t squared plus 3t minus 48. That's my formula for position. Did they ask me for that? No, they did not. They asked me what is the position of the particle at time t equals 2. So what they're asking here, they're saying what is the position, which is x, of 2. Well, now that I have a formula for x, now I can figure out what x of 2 is by substituting in 2. So 5 times 2 squared plus 3 times 2 minus 48. So I'll do all that math. Get negative 22. Now when position is negative 22, just think of that as being on a number line. So this particle moved backwards on the number line until it got to negative 22, and then it stopped. Now you'll have some similar where you have some trig problems involved. Again, I'm given velocity, and I'm asked to find position. So again, I'll start off the same way. I know position is the indefinite integral of velocity dt. I'm going to substitute in my formula for velocity. Indefinite integral of 4 pi times the sine of pi times t dt. And then I'm going to integrate. Now this one I might want to use u substitution because it's not just a t right there. So I'm going to let u be pi times t. That would mean du dt is pi. Solve that for dt is du over pi. So then when I rewrite this, position is the integral of 4 pi times the sine of u du over pi, which means that these pi's are going to divide out. Now I have that x of t equals the integral of 4 sine of u du. And I have to think, okay, what's the antiderivative of sine? It's negative cosine. So the antiderivative of 4 sine is negative 4 cosine of u plus a constant. But then I'm going to substitute back in for the u, the pi t. So x of t equals negative 4 cosine of pi t plus the constant. So now I'm starting to get an expression or an equation for position. But then I also have this initial condition right here. Well, come on, pen, work. My initial condition is saying that at time 5/3, the position is 2. So I'm going to substitute in 5/3 for t and set it equal to 2. So negative 4 cosine of pi times 5/3 plus c is equal to 2. So I've got 2 equals negative 4 cosine of 5 pi over 3 plus c. Now I'm going to have to remember my unit circle here. So what is the cosine of? So I'll pull it over here at 5 pi over 3. Whoa. 5 pi over 3 is right here. The cosine of 5 pi over 3 is a half. So negative 4 times a half plus a constant. So 2 equals negative 2 plus the constant. Add the 2. I get that c equals 4. So that's going to allow me to write the equation x of t, because I know that 4 is c right there. I'm going to put the 4 right there. X of t equals negative 4 times the cosine of pi and times t plus 4. And so what do they want me to find? They want me to find what is the position at time t equals 2. So what is x of 2? That's what they mean right there. So x of 2 is going to be negative 4 times the cosine. So I put 2 in for t of 2 pi plus 4. So x of 2 is negative 4. I've got to find the cosine of 2 pi. Let me pull my unit circle back over here. At 2 pi, which is right here, cosine is 1. So times 1 plus 4. Negative 4 plus 4 is 0. So position at time 2 is 0. Then you'll also have some further applications where you will be asked to determine if the particle is moving to the right, moving to the left, if it's speeding up or slowing down. So for those types of things, you're going to need to refer back to our motion analysis that we did last chapter. So here is a nice time if you might want to take another screenshot or write this down. You might want to pause the video, but you do need this information again because it's going to help us answer the next questions. So here we have a particle moving along the x-axis with position given by x of t equals negative 3 cosine of x. Just kidding, I'm changing the question. That one didn't require you to take Integral. So let's do this one. A particle moves along the x-axis with acceleration given by a of t equals 2 pi sine 2 pi t for time t is greater than 0. Tells me velocity. Here's an initial condition for velocity, and determine if the speed of the particle is increasing or decreasing. So if I have a formula for acceleration, initial condition for velocity, that tells me I should probably do something with acceleration and velocity. And I can tell if a particle is speeding up or slowing down based on the signs of velocity and acceleration. So if velocity and acceleration have the same side, particle speeding up. Slowing down if acceleration and velocity have opposite sides. So first of all, I need to figure out, is the speed of the particle increasing or decreasing at time 2/3? So I need to know what's happening at acceleration. So first thing I need to do is take that acceleration formula and substitute in 2/3 to see what kind of sign is going on here. So a of 2/3 equals 2 pi times the sine of 2 pi times 2/3. So a of 2/3 equals 2 pi times the sine of 4 pi over 3. So then I'll need to figure out what is the sine of 4 pi over 3. Well, 4 pi over 3, the sine is negative square root of 3 over 2. So if I multiply all that out, the 2's divide out. So a of 2/3 is negative square root of 3 pi. Okay, so I'm going to circle this because I need to remember this later. Now remember, particles, the speed's increasing or decreasing. Speeding up if acceleration and velocity have the same sign. So I found acceleration already. Now we need to figure out what's happening with velocity. Well, I don't have a formula for velocity, so I need to find one. I know that velocity is equal to the integral of acceleration. And so v of t equals the integral of 2 pi sine of 2 pi t dt. And it looks like I'll use a little bit of u substitution. I'm going to let u equal 2 pi t, which means du dt is 2 pi. And solving for dt, that is du over 2 pi. So then that's going to allow me to integrate v of t equals the integral of 2 pi sine of u times du over 2 pi. 2 pi's divide out. V of t is the integral of sine of u du. The antiderivative of sine is negative cosine plus the constant. Substitute the u back in. Negative cosine of u, we said, was 2 pi t plus the constant. So now I need to figure out what the constant is. So I'm going to use this initial condition. This initial condition says that v of 1/4 equals 2. So that means in the velocity function, when I substitute in 1/4, I get 2. So 2 equals negative cosine of, let's see, 2 pi times 1/4 would be pi over 2 plus a constant. 2 equals, let's see, cosine of pi over 2 is 0 plus c. So it looks like the constant is 2. So then I'll substitute the 2 in for the c. And that's going to give me a formula for v of t. So v of t equals negative cosine of 2 pi t plus 2. Okay, got the formula for velocity. Oh, I got to check to see what the sign of velocity is at time 2/3. So I'm going to substitute in 2/3 for t in my velocity function. What's v of 2/3? That's negative cosine of 2 pi times 2/3 plus 2. So v of 2/3 equals negative cosine of 4/3 pi plus 2. What's the cosine of 4/3? Cosine of 4/3 is negative a half. So negative a half is positive a half plus 2. That combines to be 3 halves. So for v of 2/3, I'm getting 3 halves, which would mean that 1 half plus 2. Oh, 1 half plus 2 is not 3 halves. 1 half plus 2 is 5 halves. So at 2/3, velocity is positive. Acceleration is negative. So that tells me that the particle would be the speed of the particle is decreasing because the signs are opposite. One's negative, one's positive. So the speed is decreasing. At time t equals 2/3. Now, let me show you how you're going to have to enter that. You would say, since velocity and acceleration have opposite signs, the speed of the particle is decreasing when t equals 2/3, because v of 2/3 we said is 5 halves, and a of 2/3 square root of 3 pi, negative square root of 3 pi. Negative square root of 3, and make sure you type that pi on the outside. And there we go.